Yeah, hi guys. I hope my audio and video both these two are fine, right? So, welcome to my channel. And this channel is especially to the candidates who are preparing for the UGC NET December 2023 cycle, both paper 1 plus paper 2. So, paper 2 means what we're having. UGC is conducting the NET examination for 83 subjects, but I'm not going to deal all the 83 subjects. As an electronic science candidate, I am going to deal the paper 2 for the electronic science and the subject code is 88. So who are the candidates can prepare for the electronic science subject is that if you guys belongs to ME or MTech of the electronics and communication related and ME or MTech electrical engineering related candidates. So both these two candidates or else the MSc electronics candidates also are eligible to write this UGC NET December 2023 cycle examination. Okay. So paper 1 and paper 2, both these two is going to deal in this channel, and especially the online live course is available regarding this UGC NET Electronic Science June 2023 cycle, including the paper 1, and this complete course is in the English medium only. Okay, English medium only. So if you guys are, if you belongs to some other subjects means, if you want the only paper one also, one separate online live course is available, and paper one plus paper two electronic science. Okay, both these two courses are available. So the interested candidates may approach me by contacting the number 86394 39984. Okay, 86394 39984. So it is my number. So first you WhatsApp me. Okay, and then we will see the rest of the details, like what are the things are going to deal in this course. Okay, and in what way this course is going to start, we're going to see. And coming to this course, only 30 members are eligible. Whoever the first 30 candidates are going to register for this course, only the 30 candidates are going to be done. Fine. So if you are watching this video and if you belongs to electronic science candidates, then register as early as possible. And I am taking this batch as a super 30 batch. Okay, so the first 30 candidates who are registering for this course only will be taken, and the 31st candidate will not going to be taken for this course. So because if the batch is less, then I can able to focus more in order to get the better results. Fine. So these are all the course details, guys. And if you want to take the course and all, then you may approach me. Whatever the contact number I provided, so their WhatsApp number is also there. First you WhatsApp me, the details I will send you, and if you are having still queries means, then you may contact me. Okay, so in this video, as a starting part, in this YouTube channel, the first I'm going to deal is the uh, basic electronics. Okay, we can take it as basic electronics, or else for our UGC NET electronic science examination, what are the basic things we need to understand. Okay, so from that one we are going to start. So, and this topic is going to be deal in the multiple parts in the same YouTube channel. Okay, so whatever the basics I'm going to deal in the different parts, if you are familiar with these basics, then you can able to understand the topics very well or the very quickly. Okay, so in this session we are going to see about the resistor. The first one is we are going to see about the resistor. So first of all, what is a resistor? The name itself, it is telling that which is going to resist. What is the meaning of resisting? The meaning of resisting is that opposing the things. Okay, opposing the things. So if you take any some normal copper wire, right? If you take the copper wire, then what will happen is that if the electrons are flowing through the copper wire, okay, if the electrons are going through the copper wire, then the copper wire can be taken as a series of resistors, right? Why? Because If it is a 2 centimeters of copper wire, that means L is equal to 2 centimeters. If I apply the 4 volts of DC signal, then here you may get the 3.9 volts at the output side after crossing the 2 centimeters. And in the next scenario, what I'm doing is that if I take, just a minute, guys, trying to change the. So if I take the length of the wire as this time the 4 centimeters, okay. Now if I'm giving the 4 volts of DC here, then I am going to get the something little bit, some 3.5 volts I may get. So here how much voltage drop happened? 0.1 volts drop. And here how much voltage drop happened? 0.5 volts of drop is happening. So what it means is that if the length of the wire is increasing, then the voltage drop across the wire is also increasing. And it directly mentioned that if your length of the wire is increasing, it leads to increase your resistance. That means uh, length and resistance, both these two are directly proportional. If you're increasing the length, means then automatically resistance also increases. Fine. So what is the meaning of resistance here? Opposing the, that means if the electrons are flowing like this, so if you're opposing the flowing of electrons, I mean if the electrons are flowing like this, and the resistance means it is opposing the flowing of electrons. So this opposing property, opposing the flowing of electrons property is called as a resistance. Okay, fine. And now, so in what way we can define much more about the resistance? Means usually, as per the copper wire concept I told, R is equal to rho L by A. It is the basic mathematical way of explaining about the resistance. Okay, R is equal to rho L by A. So where rho represents the resistivity and L represents the length of the wire and A represents the area. Okay, cross section, that means if you take the wire as like this, whatever the cross sectional area is there, so that is called as a area. Right. So here from this concept, what we need to understand is that if the area is increasing, then your resistance will be decreasing, because resistance in the area, both these two are the inversely proportional. And if the length is increasing, then the resistance also increases, because both these two are directly proportional. And rho is the resistivity. It depends upon the with what material you constructed this copper, you constructed this wire. Okay, fine. And basically we know that resistor is the passive element, right? Passive element means it doesn't store any type of energy. Then if I give the 4 volts here, as we discussed in the previous example, length is equal to 4 centimeters or something else. If I getting the 0.5 volts, then what about the 0.5 volts? 4 volts at the input side is getting as a 3.5 at the output side. That means 0.5 volts where it has to be go. Okay, so where it is going is that this 0.5 volts will be dissipated in the form of heat. Okay, but because we cannot create the energy, we cannot destroy the energy. So this 4 volts is equal to heat dissipated plus output voltage. So that means input energy is equal to heat energy dissipated across the wire and output energy. It is called as a law of conservation of energy. Okay, and as per the, I mean, if you're taking the resistor in this format, so basically the resistor is a passive element, right? So passive element means it doesn't store the energy, it is dissipating the energy in the form of heat. So as per the Ohm's law, usually we'll tell that if you connect some battery with some potential difference V and R, and here I is sending means, then as per the Ohm's law, what we are telling is that the V is equal to I into R, correct? V is equal to I into R. To be precisely mentioned, I need to put like here V suffix 1. Okay, so what is this V suffix 1 is that? Carefully observe. If I take here V suffix 1, fine. That means, just a minute. Okay. So V suffix 1 means here also it is V suffix 1. What is the difference between this V and V suffix 1 is that V suffix 1 is nothing but a voltage drop across the resistor. So whenever you are taking the Ohm's law means V is equal to IR, means here V is not the input voltage, V is the voltage drop across the resistor. Understand? So here also voltage drop across the resistor V1 is equal to I into R we are taking. So if it is 4 volts and if this R is 1 ohm, then here I is equal to, usually only one voltage source is there and only one resistance is there, and obviously V and V1 both these two are same. Okay, V and V1 both these two are same in the case of single resistance, right? So that's why here I'm taking V1 or V as a 4 volts, right? So if R is equal to 1 ohms and V is equal to 4 volts, then the amount of current flowing through the resistor is 4 amperes, correct? And if I took the R as a 2, okay, if I took the R as a 2 ohms, then I is equal to V divided by 2, and I will get the 2 amperes. If I take the R as a 4, then V by 4 by 4, that is equal to 1 amperes. That means if I am increasing the resistance, what's happening to the current? Current is decreasing. It is what the concept, right? What's the concept? It is what the concept that resistance is nothing but a resisting the flowing of electrons. That's why if you're increasing the resistance, then it is successfully resisting the flowing of electrons. That's why your current is decreasing. Okay, it is one thing. And next, if I take the VI characteristics of a resistor, okay, so it is the V means here the voltage drop across the resistor, and I means current flowing through the resistor. Now you are going to get the curve as like this, a straight curve you will get. Okay, so whenever the straight curve, just like a ramp type of signal you are getting, then we can call this one as a linear signal, right? So whenever the relation between the voltage drop across the device and the current flowing through the device is directly proportional, okay, then we are calling this one as a linear device. That means the resistor is a passive element, and along with the passive, it is also called as a linear device. All of you understood? Okay. Now, if any one element is said to be a linear device, then in between the voltage and the current, if we get a ramp like of signal means, then can we call as a linear device means? No. There is one more concept is there. Okay, so let's focus clearly. What is that one more concept is that if I take the two-dimensional thing as like this, if any one device is said to be a linear device, then it must have the positive slope. So positive slope you will get in the first quadrant and the third quadrant. But while coming to the second quadrant and fourth quadrant, you don't get the positive slope. Okay. So what is the meaning of positive slope means here itself? It is a plus and it is also plus. It is minus and it is a minus, right? So if you take the any some slope here means let's take any some random point. Basically it is a voltage axis and it is a current axis. So if I take the slope here m and let's extend as like this. So here I1 and here V1. Now slope can be taken as a di1 by here dV1, right? So in this case, I is also positive, V1 is also positive. So both these are the positive quadrants. I mean positive axis. So that's why we'll get positive only. So here also it is negative and it is negative. So if you take any some random point m1 here, then you will get m1 is equal to you can take the dy by dx type of thing. Okay. So in that way, and it is the y-axis, and if I take it is the x-axis. Okay. So that's your wish. So here the dy by dx means, so here also I am going to get that something. Let's take it is I2 and it is V2. So di2 by dv2. I2 is also negative axis and V2 is also negative axis. Negative by negative will be positive. So if any one device is said to be a linear device means it must have the linear relation between the voltage and current plus positive slope must be there. Okay, that is a main important point. I hope that all of you understood this difference. So for example, if I took any one line along the origin like this, then it is a negative slope here in the fourth quadrant, negative slope. Then it is not a linear. If any one device, passive device, is getting the characteristics as like this, which is crossing the second quadrant or the fourth quadrant, it is not called as a linear device. Okay. So if anyone passive device is said to be a linear element, or the linear device means one is a linear type of relation, that is ramp signal plus positive slope must be there. Okay. So it is somehow the basic concept what I want to tell you regarding this resistor. Okay. So I hope that the concept, whatever the things we discussed here, you guys understood. And to be in summarize, that the resistor is nothing but opposing the flowing of electrons. It depends upon the material what you are choosing. That is rho, resistivity, length of the material, and area, cross-sectional area of the material. Okay, and as mean this concept will be helpful to you in the as per the UGC net exam in the 10th unit, that is the transducers, or else in the first unit semiconductors also it will be helpful. Based by why? Because based upon this concept we are going to explain about the potentiometer, strain gauges, okay, and yeah, different types of RTD, resistance temperature dependent thermistors, all these concepts. And while coming to the, as per the Ohm's law, V and I, both these two are directly proportional in the case of this resistance. If the voltage is increasing, current also increases. If the resistance, if you keep on increasing the resistance, then the current will be decreasing. That is a property of resistor in order to oppose the flowing of electrons and all. And resistor doesn't store any type of energy. That's why it is called as a passive element. And resistor comes under the linear device. Why? Because if you draw the graph between the V and I, then you are going to get a ramp like of signal. And if that signal is having the positive slope, then only we will call that one as a linear device. Okay, so it is a summary of this complete thing, guys. And before closing this session, so one more time I'm explaining that if you guys are preparing for the UGC NET Electronic Science December 2023, so I am providing the intensive type of course. Okay, there is a money back guarantee is also there. So to get the more details regarding this electronic science course, so you just WhatsApp me to this number 86394399884. Okay. So or else you may just put in the comment section also. In the comment section, if you put your mobile number or else your email ID, then also I will approach you. Right. So I hope that you guys understood this concept. And tomorrow we are going to discuss about the capacitor concept. Okay. Thank you very much, guys.